Going to talk about the sum based on the theorem. The lengths of two tangents drawn from an external point to a circle are equal. Let's begin with this beautiful sum which is supported with a figure. Here the question says, a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equals to AD plus BC. Now this looks like a very interesting sum. To start with, we have a quadrilateral ABCD. So we have a quadrilateral ABCD, and this quadrilateral is circumscribing a circle. That means a circle is inside the quadrilateral. Now when the circle is inscribed in the quadrilateral, or the other way of speaking the same thing, if the quadrilateral circumscribes the circle, that means all the four sides AB, BC, CD and AD are the tangents to the circle. And P, Q, R and S are the respective points of contact for the tangents. What we need to do over here is, we need to prove AB plus CD is equals to AD plus BC. Now this sum is a classical example where we need to show the left hand side to be equal to the right hand side. So our approach over here is to take care of any one side, and subsequently we can hope to get the right hand side on its own. Let's begin with the left hand side, where we need to prove AB, rather we need to get AB plus CD. Let's talk about AB to begin with. Now, if you look at the figure, we can see AB is made up of two parts. It's made up of two segments, AP and PB, correct? Okay. Now, children, because we mentioned all the four lines are the tangents for the circle, A is an external point. And we know for sure that the tangent drawn from an external point to a circle are always equal in their length. So from A, we have two tangents, that is AP and AS, and we know the lengths are always equal. So we just write down AP equals to AS, result number 1. In the same way, B is also an external point, and from B there are two tangents to the circle, BP and BQ, and according to the property, the lengths are going to be equal. So PB equals to BQ, result number 2. Okay, what else? So we got AB, we got the parts which is going to make AB. Let's talk about CD now. If you look at the figure, again CD is made up of two segments. It's made up of CR and DR, that is RD. Again, we have two external points that we can consider, and we know from each of the external points, the tangents drawn to the circle are equal in length. So let's talk about C. So from C, one of the tangent is CR and other has to be CQ. So we now say CR is equal to CQ, result number 3. What about D? So from D, we have one tangent as DR and the other tangent is DS, and the lengths are equal. So RD equals to DS, result number 4. And the reason is very simple. The reason is tangents from an external point to a circle are equal in their lengths. Now what? Since we need AB plus CD, it's very simple to do. We just need to add 1, 2, 3 and 4. We add the left hand side to the left hand side and the right hand side to the right hand side. So let's add the left hand side first. Adding 1, 2, 3 and 4. We now get AP plus PB plus CR plus RD, which is now equals to the right hand side, that is AS plus BQ plus CQ plus DS. Now children, we have to follow a very important step. Now, what we need to do is, we need to pair the two segments in such a way that the collinear points or the collinear segments need to be together. If you look at AP and PB in the figure, they are collinear segments. They are on the same line. So let's pair them up. So AP plus PB is together enclosed very safely in a bracket. In the same way, CR and DR are collinear segments. We put them together. The right hand side requires a little detailed listening and understanding. Okay, look at AS. AS will be collinear with which segment? DS. So let's bring them together. AS plus DS. So by default, the second pair has to be BQ plus CQ. Why are we doing this? Why are we pairing such segments in such a unique way? Let's see what happens. Look at the figure. AP plus PB. AP plus PB will form a new segment, and the new segment will be AB. The reason is A dash P dash B plus CR plus DR forms a new segment, and the new segment is CD. So AB plus CD is something what we already wanted right from the beginning, and we have it, which is now equals to AS plus ds. AS plus ds becomes AD, A dash S dash D, plus BQ plus CQ. If you look at the figure, it becomes BC, B dash Q dash C. So we now have, children, AB plus CD is equals to AD plus BC, and check. That's what we need in the sum.